Machine learning is a buzzword in the technology world right now, and for good reason, it represents a major step forward in how computers can learn. So, hello and welcome all to this YouTube session. This is Atul from Edureka, and in today's session, we'll be dealing with top 10 applications that are using the power of machine learning in new and exciting ways. This is done by Facebook's face detection and recognition algorithm, which is based on the advanced deep learning research project called DeepFace. Well, DeepFace is a deep learning facial recognition system created by a research group at Facebook. It identifies human faces in digital images. For example, in this picture, the Facebook is automatically identifying the person in the picture and is asking me whether I want to tag that particular person or not. And just to tell you, yes, it has predicted the person correct. Next is the auto alt tags which we get in Facebook. So in order to explore it, you need to perform a series of tasks. So first of all, you need to open an image in Facebook and right click on it for inspect element or press the F12 button. And then check the inspector tab for the HTML code for that particular image. Now check the alt element content. It will give you a general description of the image, like number of persons or whether they are he, she, are sitting, standing, laughing, if it is a close-up pic, it's a screenshot or anything, right? For example, in this case, what do you see? You see an image which is somewhat related to or contains clouds, trees, natures, etc., right? Let's see what Facebook has to say for it. Well, when you inspect the elements, you will see that it has automatically identified the image and added relevant alt tags with it, which suggests or gives a rough idea of what the content is in the image. So here, the machine learning is suggesting that this particular image may contain tree, sky, plant, outdoor, and nature. Really cool, isn't it?
Learning. Classification is a process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data. The process starts with predicting the class of given data points, and the classes are often referred to as target, label, or categories. The classification predictive modeling is the task of approximating the mapping function from input variables to discrete output variables. And the main goal is to identify which class or category the new data will fall into. So let's try to understand this with a simple example. Heart disease detection can be identified as a classification problem. This is a binary classification since there can only be two classes, that is, has a heart disease or does not have a heart disease. The classifier in this case needs training data to understand how the given input variables are related to the class. And once the classifier is trained accurately, it can be used to detect whether heart disease is there or not for a particular patient.
Hello people, welcome back to my channel. The topic for today's video is association rules. So association rules is one of the major branch in data mining or in machine learning where you want to do the pattern search or pattern extraction from a set of transaction or items. So
you can think of linear regression as the line of best fit. So the line of best fit can be
unsupervised learning. Let's take a look at the topics that we shall cover in today's session. It is broken down into two parts, which are association and clustering. So Amazon learns from the customers' purchase and recommends them the products which are frequently bought together and so on. And from unsupervised learning, we have a set of parameters on which we shall differentiate the two. We have data sets, we have the method of learning, we have complexity, we have accuracy. So let's see how these fare against each other. So in supervised learning, the data set is always labeled, whereas the data set is unlabeled in unsupervised learning. The method of learning in supervised learning is guided, meaning that you are guiding the algorithm to learn. Whereas in unsupervised learning, algorithm learns by itself using the data set. And so for the complexity, unsupervised learning is much more complex than what we have for supervised learning. And supervised learning are more accurate rather than unsupervised learning, which may be lesser accurate. Now, understanding the differences between each other, let's move over to the last topic.
Computers that can play games have always impressed the computing world. In December 2013, a small group of AI researchers from a London-based company called DeepMind released a groundbreaking paper called Playing Atari with Deep Reinforcement Learning. And just a little over a month later, Google announced that they had bought DeepMind for a really big sum of money. Since then, there's been all kinds of talk about reinforcement learning in the field of AI. In January of 2016, Google announced that the appropriately named AlphaGo was able to beat the reigning Go champion of the world. We're going to take the mystery out of reinforcement learning so you can see how all these amazing feats are possible. The story of reinforcement learning goes all the way back to AI, animal psychology, and control theory. Smart-sounding way to say supervised learning. Supervised learning is all about making sense of the environment based on historical examples. But that isn't always the best way to do things. Imagine if you're trying to drive a car in heavy traffic based on the road patterns you observed the week before when the roads were clear. That's about as effective as driving when you're only looking at the rear-view mirror. Reinforcement learning, on the other hand, is all about reward. You get points for your actions, like staying in your lane, driving under the speed limit, signaling when you're supposed to, things like that.